techniques I want to share with you. The tape diagram is a technique that they like to have you do, which is pretty simple. When they're tied at 3 and 3, you really only have to look at the fraction, is that right, to see who breaks the tie. So today I'd like to show you kind of an easy step. If you understand it, you'll understand why it works. But I got to show you, tricks usually only work, well, they work, but if you don't know why they work, a lot of times I can't show you a magic trick. You know, I can't make something disappear if I don't understand how the trick works. Tricks are used by people to make their life a little easier, or to trick is some way like, it looks magical. How did you do that? Well, today we're going to try to understand what is basically a magic trick for math. Okay? But you'll say, I know how the magic trick works. Then it's not really a trick to you. It's just a tool. Okay? But if you don't understand why the trick works, you'd be like, oh, I just used this. It seems to work every time. I don't know what it is. Yeah, even that would be magic even to you. I reach behind my ear and I find a quarter. Okay, that's a magic trick. Look what I did. How'd you do it? I don't know. Then it becomes, that's a weird, yeah, you do know it. Do you know a trick? Yes. How you do it? I don't even know what you do. 2/3 compared to 6. So what we're going to do is draw a tape diagram, and underneath I'm going to draw another one. I'm going to break one into 6 and one into thirds. So this one's thirds, this one's thirds also, but in sixths. So I see our thirds are lined up exactly in the same spot here, so I'm going to shade in 2/3. And then this one I'm going to shade in the 5/6. 1, 2, 3, 4, 5. This one definitely beats it, so it's the bigger of the two. That's a great, is that a trick? No, because you understand it, right? It's a way of showing it and understanding it. We'll do the next one kind of the same way. Those just show you exactly which one's bigger. This is equal to 2/3. And this one's equal to 5/6. The next one, we're doing 2/5 and 6/10. Now, some people wouldn't really have to draw, they wouldn't have to draw a tape diagram unless it was required of you. If it says to draw a tape diagram, of course you could go ahead and draw 2 tapes. But most of us look at this and we do the rule of 1/2. Right? We look at this, we're like, they're tied for 3 and 3. So which one is the tiebreaker? Which one, excuse me, well, the fraction is the tiebreaker. But which one beats the 1/2? I tell it, does 2/5 beat a half, or does 6/10 beat 1/2? Which one is more than half of it? Well, let me draw the fifths for you real quick, okay? So 1, 2, 3, 4. There's fifths. Let me draw tenths, which would be double those. There's the fifths, right? And the tenths would be even more of them. I'm going to draw 6/10. 1, 2, 3, 4, 5, 6. That equals 6/10. And this is equal to 2/5. 1, 2/5. Now, visualizing them, we only have 2 pieces out of 5, so we're not even to halfway yet, right? This one's got 6 pieces out of 10. It's halfway is 5, so if you beat the 5 point right here, if you're going past the halfway point, this one wins. How many people could easily show these with tape diagrams? If you had to, you could probably show them in yeah. Now, how about a little interesting twist? Colin and many of you know how to make equivalent fractions, where 2 fractions can become the same fraction. We can rename fractions. What if they all had the same denominator? Would your life be simple?
Yes.
Okay. Yeah, totally simple, right? If this was a 6 and this was a 6, no problem, we would know what to do.
Right.
It's like, that would be like 3rd grade math, or even, maybe,
Right.
So how do we do that quickly and easily? Well, here's a new method for you. Colin says, if you want to know which one's bigger, 3/6 or 1/3, change this 1/3 and make the bottom number become a 6. Yes.
I know how to do that.
How do you do that?
You multiply 3 by 2 and then 1 by 2.
Oops, I did an X again. That's weird. And what do you get for an answer? 1 times 2 is 2. 2, 6. Ah. Now this is equal to 4 and 2/6. And you know which one's bigger now? Which one do you like for, which one's bigger, Vivian?
6. I like 3-6.
Yeah, the 3-6 beats the 2-6.
I like that.
That method's kind of cool, right?
Yeah.
Okay.
I like that.
I like that too. What about this one? 5/8, 19/4. This is kind of a no-brainer though. This one jumps out, you're like, okay, the whole number is right here. I don't have a whole number, so I'm stuck. What should I do first? What do you think, Zeta? What do you...
Figure out what
The improper fraction is first? Okay.
It is.
What is it?
4 3/4.
4. That gets us to 16. And 3 more. Did you see what she did there, Attila? She said, inside of here, there's a 4/4. And another 4/4. And another 4/4. Oh boy. And another 4/4, because she knows that'll get you to 16/4. Plus 3 more fourths. So she said this part is 4 and 3/4. Now, I look at this, and 3/4 or 5/8 might be a little confusing, right? It doesn't jump out at you because they're both, well, one's more than half, though, right? Which one's more than half? Kate.
Both of them.
This is more than half, right? And this is more than half.
Yep.
So let's make their denominators the same number.
Yeah.
Colin, how do I make 3/4 become 8s?
You have to multiply the top and bottom by 2.
By 2, by 2. Which one beats it? Is it 6/8
Yep.
or is it 5/8?
6.
Gotcha. So this is bigger because the 6/8 is what 3/4 is if you renamed it. Kind of cool. Yeah. Now, here's a fun thing to do. I'm going to go to Untitled page. Oh, this is Untitled. I got lots of. How about a new one? I don't want to do that.
What happened?
Okay. So let's say you've got two fractions. You're not exactly sure which is the bigger fraction, right? So can you put the paper away? Can you put the paper and the scissors away? That's not away. That's on top of your desk. Away would be inside your desk. Okay.
Or your cousin.
All right. Let's take out your math notebook, the one that we did the notes in. We're going to take a look at a trick.
dot.
Are you ready for a trick?
Yes.
Okay. So let's say you got 9/15 and say 2/3. All right, here's a couple. So you're like, which one's 9/15 or 2/3? Which was the bigger one? You might have a feeling for it, but is there a way to prove it? Well, one way is that we can come up with a common denominator for each and turn them both into 30ths, right? We could turn them both into 30ths. And in this case, we could say, hey, 15 times 2 and 9 times 2 is 18/30ths. And 3 times 10 and 2 times 10 is 20/30ths. Since they have the same denominator, we can see which answer is bigger. Kind of cool, right? 18, so we know that this one is bigger than that one. Did everybody have a chance to write that down in their notes?
Yeah. Wait.
Now, a method we could use is called the butterfly method, where we can actually compare the fractions quickly and easily. We know we'll show another one here. This one's an example. Are we going to the next page? Is Chloe ready?
Yep.
Everybody all set?
No.
No? You hold on.
Done.
Done?
Done.
You guys are good? You want to try another example?
No.
Okay. No?
Yeah.
Yeah?
No.
Who's waiting for me here?
I'm
Done?
done.
Next example, let's say you got, I don't know. Now, in this example, we can make them into 50ths really easy. They can both become 50ths really fast, right? Yep. Times 10 here, times 10. is 30 times 5 here, times 5 here, and we've got them in 50ths. They both became 50ths. 7 times 5 is 35. Yes?
I know something.
Mm-hmm.
You have to do 5 times 10 and 10 times 5. You
That's
can't
it.
just swap the 5 and 10.
Right. He's noticing that the denominators just get multiplied together, and the answer is underneath. Good find, right here. Just taking the denominators, as long as you multiply the two denominators by the same number, they always get the same answer, don't they? 3/5 and 7/10. All right. Is everybody okay with that? Did everybody get a chance to write that down? 3/5 and 7/10. Let me just shrink this down for you. 3/5 and 7/10 we'll use again. I'll put that right there. Oh, whoa, whoa. Let's move that up here. 3/5 and 7/10. Oh, well, I kind of messed up one of the numbers there. 3/5 and 7/10. Since we could do that method, what if we did this? 3/5 compared to 7/10, and we do a thing called the butterfly method. Are you ready? What is 5 times 7? 35. What is 10 times 3?
30.
Are those the two numbers that we just compared to see which one wins?
Yeah.
Oh,
Oh.
so 7 times 7.
Oh, it looks like a butterfly.
It does. It does look like a butterfly. Okay. Now, the answers go on the top, up on the top of his wings up here, but they're the same numbers that we came up with to compare. We would know that the answer would be the denominators is 50 over 50, but we don't have to do that math because we know the denominators will be the same number. Okay, so it's a 30 over 50 compared to 35 over 50.
That's cool.
Kind of a neat method. Quick. You've really done equivalent fractions, but you've skipped the step of multiplying the denominators. Pretty wild, huh? Okay.
I like that method.
Okay, that's another way of showing if you couldn't figure out which is which. Let's go back to our math. We'll go back to our math and see if we can figure out some of these on here using the butterfly method, just for fun. Okay? All right. Let's say we're comparing this one. This is a little weird here. 5 and 7. 3/5 compared to 18/7. All right, we're going to see which one's the bigger fraction here. Would you say that this one, 7 times 3 is 21? Okay. This is strange because we've forgotten the 2, though.
We could change 3/5 to a improper fraction.
Let's do that. Since we don't have all the fraction in there, we'll back up.
So it's 13.
It's 13/5.
5 times 2. If you want, we'll try this big improper fraction, see if it works. 5 times 2 is 10, plus 3 is 13/5. And we're going to compare it to 18/7.
That's gonna be a lot.
Whoa, this looks weird and hard, doesn't it? I don't know if I want to do that kind of math.
I'll do it.
If you had a calculator, you could figure it out real
Well, look
quick.
who has a calculator.
And
Looky,
who
looky.
else has a calculator?
5 times 8 is 40. Carry the 4. 1 times 5 is 5, plus 4 is... This answer is 90 on top over here. 7 times 3 is 21. Carry the
90
2.
and 91.
91 on this side. Whoa.
Right as he said calculator.
That's a method you could use. Probably this would probably not be my method for this one here because it's got this improper fraction in it. I would probably have pulled how many sevens were in here. Can I erase this for now? Is everybody okay with that?
Yeah.
Okay.
Wait. Hold on. Okay, go ahead.
I would probably have gone this route. I would say this method. I would say I would go 7 over 7, another 7 over 7. There's 14 sevenths and another 4 sevenths. Would you guys do it that way?
No.
Because isn't this 14 sevenths?
Just rude.
Who said, somebody said wait. Somebody say wait?
No.
Chloe said rude.
Am I okay with, is that 2 and 4 sevenths compared to 2 and 3 fifths?
Yeah.
And then I would probably compare the 3 fifths to the 4 sevenths to make my life easy, right, Xavier? Would you do the butterfly method on this one? You could. 5 times 4 is 20. 7 times 3 is 21. This one beats the other one because it would be 21 35ths over 20 35ths. We don't have to figure out the denominator because we know it's going to be the same number. We figure the top number is going to win. We know that when you have the same denominator, the top number beats the fraction. It beats so the butterfly method. Woohoo! Thank you, Mr. Butterfly. You tell us which one's bigger if we just cross and find out the top answer. Isn't that fun? It's kind of a fun way to do it. Do you understand why it works? Because we're making equivalent fractions. We could have called, what's that?
It's like cross-multiplying.
It's a little bit like cross multiplying. If we cross multiply, we'll find that these are not the same. 5 times 4 is 20 this way. 3 times 7 is 21 this way. We're going to find out they're not equivalent fractions. But when you go the opposite way and put the answer up here, it tells you which one's the bigger of the two. So it's almost like cross multiplying. When you find out they're not equivalent, you can then find out which one wins. Okay? Let's see. Is 3/8 the same as 1/3? Well, let's compare. Using cross multiplication, let's find out. Whoops, I'm sorry, I put 2 down there.
Leonard, can we use your butterfly method if we want to?
You can. If they ask you to explain it, if they show your method, you can do it that way. You can do it. 3/8 compared to 1/3. Are they equivalent? Let's find out. We can cross multiply to see if they're the same number. 8 times 1 is 8. 3 times 3 is 9. Now, the butterfly method will show us which one wins. We're going to put the winning number on top. 8 times 1 is 8. 3 times 3 is 9. This one wins. It's based on the answers of your cross multiplication. But if they aren't the same number, then they're not equivalent. Isn't that wild? Okay? All right, so 3/8, we're calling 3/8 9 24ths. And we're calling 1/3, we're calling it 8 24ths. Why? Because we changed both 3 and 8 to the 24ths. We didn't bother doing it down here. We could have put 9 24ths under here because it's going to be the denominators multiplied together. So we changed 2 and 3/8 to 2 and 9 24ths. And we changed 2 and 1/3 to 2 and 8 24ths. But we didn't do all the work of rewriting them. We just said, oh, there's going to be 9 of these and there's going to be 8 of those. Is that a sweet deal?
Yeah.
Pretty sweet. So there's so many ways for you to attack this problem. You've got lots of tools in your tool chest. Could you make 3/8? Yeah, you could do 3/8. You go 1, 2, 3, 4, 5, 6, 7, or something like that, and you could shade in 3/8, and then you could go through and shade in 1/3. But you might, in a tape diagram, if you don't draw it very well, they look almost the same, don't they? Then you go, they're equal. 2 and 3/8 looks the same as 3 and 1/3 because the tape diagram looks like they're exactly the same. And you could get the answer wrong, and a kid be like, but Mr. Leonard, I drew it, and it looks perfect. I'm like, yeah, I know, but there's other ways to decide. And if you multiply 8 times 3, you're going to get a denominator that's 24. And the top numbers become apparent when you use that butterfly method. You're like, oh, it's so simple. I love this thing, don't you? Plus, I love butterflies. You don't? What's wrong? All right, let's see if we can use the butterfly flutterby method. Okay, 4 and 8. Let's look and see. What happens with this one, guys? When the top number is the same, how do we determine which one's the bigger fraction? Which one's got the bigger the bigger numerator's got smaller pieces, right? So which one do you like here? The left one or the right one? Which one? Hold up a hand. Which one is bigger? 5 3/4 or 5 3/8? Which way are you going? This way? This way? Yeah, the 3/4. Cool. If you want to check your answer though, watch this. Put your 3/4, put your 3/8 over here. If you want to check, you can do the butterfly method. You're going to notice that they're not equivalent, right? 3 times 8 is 24. 4 times 3 is 12. They're not equivalent. 12, 24. Which one wins?
24.
This side wins. Beats them. Sweet deal. Could you have drawn a tape diagram? Sure, you could have drawn the tape that shows 3/4. Right? You go 3/4, or then you could draw 8s. And you could show 3/8 was shorter. If they ask you to do that, you can go ahead and draw a tape diagram. Okay. You can show more than one method as long as they're asking you. Compare each fraction using this, using any strategy. Any strategy you want. Okay. Now Colin would just say change fifths to tenths. He'd like, just do this, to change 2/5 to tenths. And you've got your answer, right? They're like, oh wait, that's 4/10. Which one's bigger, 4/10 or 8/10? And he's like, you got the answer. It's definitely 8/10 is bigger than 4/10. Or if kids are like, what about the butterfly method? Mr. Leonard, what about that butterfly method at 8/10? Could I figure out which one wins? Yeah. 40 on this side and 20 on this side. 40 still wins. He's the bigger one. How many people have a number of ways of deciding now? Tape diagram, equivalent fractions, butterfly method. Do you have too many methods? Is it confusing? Uh-oh, improper fraction. Alert, alert. I have to get rid of this thing. I don't want it. How many 5/5s can I get? 25/5 and 2/5. What's 25 divided by 5? It's 5, right? Xavier, what's this turned into a mixed number? What's 27/5? How do you do it? Talk me through it. I know, wait, what is not really helping me right now. 27/5. How do you change it to a mixed number? Because right now it's improper. Do you know how to do that? Is that something you know how to do, or is that kind of confusing? The easiest method, if you want to take time, is to pull a 5/5. Is that in there? Yeah. Is there another 5/5? How many fifths do we have now? 5 and 5 is 10 fifths. Pull another one out. We got 15 fifths. Pull another one out. We got 20 fifths. Pull another one out. We got 25 fifths. We're trying to get to 27. How many more fifths do I need? 2 more fifths? Okay, 2 fifths. So can you tell me what the mixed number would be? How many whole numbers have we got there? 5 and 5 and 2/5. Cool. Now, which one of these is bigger than half? 6/10 or 2/5? I'm going to use the rule of half just to see which one's bigger than half. Is 6 out of 10 half, or is 2 out of 5 half? Which one's bigger than half? You whispering in his ear, are you, over there, Colin? You seem to be having a good time. 6 out of 10 is bigger than half? Yeah, because 6 pieces out of 10, right? You got 10 pieces. You got one more than half, isn't it? It's 1 more tenth than half. So you're going to go this way and say that's bigger because it's a rule of half. Yes?
You wrote a 2 instead of a 5.
Yeah, there's a 1, 2, 3, 4. There's 5. That's 25. That's 25 fifths. 2 more makes 27 fifths. Does that make sense? Oh, I did it up here?
Yeah, but
Oh, I wrote a 2 here. Oh, that is weird. Sorry. Yeah, you're right. That should have been a 5. Sorry about that. Good call.
Good observation.
Good observations. Yes, very good. Rule of half work here, guys? Yeah, it's bigger than half. That's bigger than half. Cross? How about butterfly method? Pull the 2/3 down. Pull the 9/15 down. These aren't too hard to multiply. What's 3 times 9? 15 times 2? That's one you should probably know. 30. Boo! Yeah! Nailed it. Nailed it.
Leonard, can we finish these on our own?
Go for it, kiddos. What you got?
Can I have a different pencil?
Did you do a new pencil?
Breaking?
Breaking?
It keeps breaking. Every time I sharpen it, it breaks.
Oh, that's weird.
Mr. Leonard.
Yeah. That's cool. It's a 105 to the 100. That gives you the winner. That's right. 100 beat 105 though? Oh yeah, it's still going. Thanks.